Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about molecular modeling. How molecular modeling is important in drug action designing. So I will discuss here from the beginning and from the scratch. So let us start with the introduction. You know, my friend, molecular modeling is defined as theoretical method and computational technique used to mimic the behavior of molecules and molecular system. You know, molecular modeling helps the scientist to visualize molecule to discover new compound for drugs. The common feature of molecular modeling technique is the atomistic level description of the molecular system. The goal to develop a sufficient accurate model of the system so that physical experiment is not necessary. Why medicinal chemistry use models? To help with the analysis and interpretation of experimental data, to uncover new laws and formulate new theories, to help solve new problems and hint solution before doing experiments, to help design new experiment, to predict properties and quantities that is difficult or even impossible to observe experimentally. So molecular modeling strategies, direct drug designing and indirect drug designing. What is the meaning of direct drug designing? We have to understand. You know, direct drug designing in this approach, the three-dimensional feature of known receptor site are determined from X-ray crystallography to design lead molecules. Here, receptor site geometry is known. The problem is to find a molecule that satisfies some geometry constraints is also good chemical match. After finding good candidates according to these criteria, a docking step with energy minimization can be used to predict binding strength. So what is the indirect drug design? You know, the indirect drug design approach involves comparative analysis of structural feature of known active and inactive molecules and that are the complementary with their hypothetical receptor site. You know, if the site geometry is not known and is often the case, the designer must base the design on other ligands molecules that bind well to the site of receptor. So molecular modeling methods, you know, molecular modeling in drug design is performed by two most common methods, molecular mechanics and quantum mechanics. And both these methods produce equation for the total energy of the structure. So let us learn about some important term about the molecular mechanics. Molecular mechanics is used for calculation of energy of atom, force on atom and their resulting motion. Energy of the atom, force on atom and their resulting motions. Molecular mechanics is used to model the geometry of molecules and motion of molecules, used to get the global minimum energy structure. Method used to study molecular mechanics of molecules are potential surface, a study of force field, and electrostatics. So, potential energy surface PES is defined as a function of nuclear coordinates, the variation in the potential energy associated with the geometry of the molecules. And PES should not depend upon the absolute location of atom, only on their locative location relative to one another, the molecular geometry. In order to reduce computational time and empirical fit, the potential energy surface is used. So, study of the force field. Force field is a set of parameters used to describe the total potential energy of the molecule or system as a function of geometry. The total energy is the sum of Taylor series expansion for stages for every pair of bond atoms and adds additional potential energy terms coming from bending, torsional energy, van der Waals energy, electrostatics, and cross torque. Now, total energy expression. Energy of system is a sum of all interaction within the between the spring. You can see the E total, valence, cross term, and non-bonded. So valence term energy, you can see valence term in the relative energy of a spring. So valence term are interaction within the spring. A spring want to relax so to its original shape. Valence term you can see. So cross term is due to coupling between two springs. It is a correlation to independent spring models. So non-bonding term is interaction between two balls. You can see here the equation non-bonding. So a study of electrostatics. It involved the study of interaction between various dipoles. All atoms have partial charge, like in CO, carbon has partial positive charge, oxygen have partial negative charge. Two atoms that have the same charge repel one another. In many cases, molecules made of neutral groups sand into adjacent atoms have opposite charge and behaves like dipoles. So electrostatic energy falls off much less quickly than for under van der Waals interaction. It may not be negligible even at 30 angstrom. So quantum mechanics, quantum mechanics provide information about both nuclear position and distribution. Based on a study of arrangement and interaction of electrons and nuclei of molecular system, it does not require the use of parameters similar to those used in the molecular mechanics. It is based on the wave properties of electrons and all material particles. So mathematics of wave motion apply to electrons, atomic and molecular structure. So quantum mechanics is based on Schrodinger equation SI is equal to E psi is equal to U plus K psi. E energy of the system relative to one in which all atomic particles are separated to infinite distance. H Hamiltonian for the system. It is an operator, a mathematical construct that operates on the molecular orbitals and psi to determine the energy. U potential energy, K kinetic energy, and psi wave function describe the electron distribution around the molecules. So Schrodinger equation is simplified by Born-Oppenheimer approximation and Hartree-Fock approximation. You know Born-Oppenheimer approximation. It treats the electronics and nuclei motion separately. Nuclei is more heavy and static than electrons, and hydrogen broken into two terms like kinetic energy and potential energy, Coulombic potential. You can see SI is equal to E psi is equal to SI is equal to K plus mu psi E psi. SI is equal to minus half E square plus 1 by R psi is equal to E psi. So Hartree-Fock approximation. This is a variation calculation, meaning that the approximate energy calculated are all equal to the greater than the exact energy. The energy are calculated in units called Hartree is equal to 27.2116 volt. So Hartree-Fock calculation start with an initial gauge for the orbital coefficient using a semi-empirical method. And this function is used to calculate an energy and a new set of orbital coefficients. And this procedure continues frequently until the energy of orbital coefficient remain constant. So molecular modeling step. Lead molecules, energy minimization, conformation analysis, conformation search, pharmacophore modeling, and QSR studies. Steps in molecular modeling. So what is lead molecules? One by one we will discuss. Lead molecule is molecule that has pharmacological or biological activity likely to therapeutically useful, but they still have suboptimal structure that requires modification to fit better to the target. Lead molecule is a starting point for chemical modifications in order to improve potential uh, uh, lead molecules is a starting point for the chemical coefficient in order to improve potency and selectivity or pharmacokinetics parameters. Furthermore, newly invented pharmacologically active moieties may have poor drug likeness and may require chemical modification to become drug like enough to be tested biologically or clinically. So, natural materials are the sources of lead molecule. For examples, local anesthetics from cocaine, anti-cancer agent from Taxol. So, energy minimization. It is the systematic modification of the atomic coordinate of a model, resulting in a three-dimensional arrangement of the atom in the models representing an energy minimum. A stable molecular geometry to be found without crossing a conformation energy barrier. So energy of molecule must be minimized so as find the most stable structure of a molecule. The lead molecules make several changes in its atom positions through rotations and calculates energy in every position. And this process is repeated many times to find the position with lowest energy. The stable form of the molecules would be the one with the lowest energy conformation. So conformation analysis. Conformation analysis generally means structural arrangement. Conformational analysis you need to identify the ideal conformation of a molecule. It is done by exploring the necessary energy surface of molecules and determining the conformation with minimum energy. So the biological activity of molecule is strongly dependent on their conformation. So look at here n is equal to 360 by delta and n is conformational, delta rotational increments in degree, n bonds and hash of rotation bond degree of freedom. So you know three notable bonds 30-degree increment conformation generated and time 29 minutes. So 5 rotatable bonds 30-degree increment conformers and time 69 hours. Time for 7 rotatable bonds 415 days. Explores large release regions with high energy. Not good for highly flexible molecules. So, in this flow chart, all the bonds length and angles remain fixed throughout the calculation. And this finally determine the spatial arrangement of functional group of the respective molecule. So, identify all notable bonds, rotate bonds through 360-degree by fixed increment, generate a new conformer, energy minimization, minimum energy conformations, all possible torsion angles combination have been generated and minimized. So limitation of conformation analysis. Each energy term has no absolute meaning. Only the sum of energy term could be used. So force field are best used within the class of compound. Parameters in the force field are not transferable to others. So properties related to electronic structure, electrical conductivity, and optical rotation, magnetic are not the accessible. So conformation search. Ligand flexibility is a matter of concern in conformational search. As a chemical structure is constantly changing shape, the notable bond gives ligand inherent flexibility. A ligand can adopt numerous conformations as it attempt to bind within the active site. So conformation search strategy, increasing the rotation increment as much as possible. Freezing bonds that do not contribute useful information. Methyl groups can be treated as united atom in many force fields. So separated bond rotation into two or more interacting classes and sampling conformation separately for each class. Breaking molecules into pieces and sampling conformation separately each piece, parents and substituents moiety. My friends, this is important points for you. Write it down. Systematic energy sampling can be used to explore full range of conformation space to find actual minimum in the energy functions. So pharmacophore modeling. The pharmacophore is a group of atoms, functional group, common for active compound with respect to receptor and essential for its activity. You also note it down here, hydrogen bond donors and acceptor, positively and negatively charged group, and hydrophobic regions are typical feature. A 3D pharmacophore is developed in which the pharmacophore elements are arranged with respect to space. So receptor mapping The volume of unknown receptor binding cavity is derived by the looking at the pharmacophore group and localized charges on the active ligands and hence assigning the active site. So pharmacophore modeling can be done by ligand based and structure based. So you can see here pharmacophore by examples. You have procaine and cocaine. Both have anesthetic properties. QSR studies indicate that pharmacophore binding site is related to the presence of ester, amine, and aromatic groups. So pharmacophore have indicate not only the presence of same function group but also the presence in the same relative position. So receptor map posed for procaine and cocaine. Now, ligand-based pharmacophore modeling and receptor-based pharmacophore modeling. You know, the first category is about finding ligand for a given receptor, which is usually referred to as database searching. In this case, a large number of potential ligand molecules are screened to find those fitting the binding pocket of the receptor. And this method is usually referred as ligand-based drug design. And key advantage of the database searching is that it saves synthetic effort to obtain new lead compounds. Now, for the receptor-based pharmacophore modeling, in this case, ligand molecules are built up within the constraints of the binding pocket by assembling a small pieces in a stepwise manner. And these pieces can be either individual atoms or molecular fragment. And key advantage of such method is that novel structure not contained in any database can be suggested. So you can see the flow chart. Now, molecular modeling. It is a process of predicting the protein ligand complexes in which the ligand molecules interact with the binding site of receptor. The ligand protein interactions are various types: van der Waals, electrostatic, and hydrogen bonding. Successful docking methods search high dimensional space effective and use a scoring function and that correctly rank candidate docking. You can see here the target ligand molecular docking. So step in ligand protein docking. This is the steps. So key stages in the docking: receptor selections and preparation and ligand selection and preparation. Build a receptor. The 3D structure of receptor is downloaded from PDB and this receptor must be biologically active and stable. Identification of active site. The receptor can have many active sites but intested ones should be selected. Ligand can be selected from PubChem, ChemSketch, and docking. The ligand is docked onto the receptor and the interactions are checked. The scoring function generates a score depending on which the best fit ligand is selected. So de novo ligand design. If one failed to find a molecules with desired interactive group by docking method, then alternative is to construct a ligand having the active group placed in a way that can interact with the interaction site identified earlier. And this ligand constructions process is called de novo ligand design. And two categories of de novo ligand design are growing and linking. So you can see the growing, docking, and linking. So linking, the fragment atom or binding block are either placed at a key interaction site and they are joined together using predefined rules to yield a complete molecule. And linking groups are regenerated to satisfy all required conditions. Look at here the scheme. So molecular dynamic method and scoring. What is the difference between them? The building blocks are initially randomly placed and then by molecular dynamic simulation allowed to rearrange. And after each rearrangement, certain bonds were broken and process repeated. And during this process, high scoring structure were scored for later evaluation. So scoring, each solution must be tested to decide which is the most promising and this is scoring. A scoring functions, guide the growth and optimization of a structure by assigning fitness values to sample space. Empirical scoring functions are a weighted sum of individual ligand receptor interaction. So quantitative structure activity relationship QSR. The explanatory for structure with the activity data and predictive for a structure without activity data. A QSR, quantitative structure activity relationship, can be used to explain or optimize the localized properties of molecules such as binding properties and whole molecules properties such as uptake and distribution. So QSR must correlate general properties of molecules with their biological activities. So my friend, the earlier example of QSR were Hunch analysis and Free-Wilson analysis. So Free-Wilson defined a function that equate activity defined as log of I concentration with weighted description, the weighting or coefficient being determined by linear regression, and that is we have the equations. So where C is the concentration required for activity are the descriptive values, usually 1 or 0 to represent absence or presence of future, and A1, A2, A3 are the coefficient and derived from the linear regulations. Now, conclusions. Molecular modeling is an inexpensive, safe, and easy to use tools. Visualize the 3D shape of molecules, carry out complete analysis of all possible conformation and their relative energies, predict the binding energy for docking a small molecules, that is a drug candidate with a receptor or enzyme target, producing blockbusting drug, and molecular modeling, if used with caution, can provide useful information to medicinal chemist in medicinal search. So this is the some papers you have to write and read it. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.